132. How far did we get on 132 yesterday? We finished it. Excellent. This one too? The candies? I don't remember doing Rylan and Miss Smith. So let's go over Miss Smith. Miss Smith puts a variety of wrapped chocolate candies into a bag. There are 5 silver wrapped candies, 1 purple wrapped candy, 2 striped, and 4 gold candies. What do I have to do there with all of those candies right now? Not yet. I am going to make a proportion later, but what do I have to do once they list all the candies? Not yet. Not yet. A fraction with what? What goes in the fraction? Pardon? Okay, before I start trying to solve, y'all, I haven't even finished reading the problem yet. What do I have to do? I need the total. So, they gave me all these candies. What's the total?
315.
15 is one total. I need to add them all up. Absolutely. So, I haven't read the 15 yet, but I'm going to need that. So, 5 plus 1. 5 plus 1.
6.
Plus 2. 8 plus 4. 12. There we go. So, these are my totals. Now I can finish reading. If 15 students select one candy at a time out of the bag without looking and replace the candy after each draw, how many students would be expected to select a gold wrapped candy from the bag? So then what goes on top?
4.
What's 4?
Gold.
The gold wrap. Also, I need all of these, especially the gold. So then what goes here?
1.
What goes here?
X.
X. I don't know what goes there. I have 4 twelfths though. What can I do with 4 twelfths? Simplify it to what?
1/3.
A third. What's a third of 15?
5.
5. 1/3 of 15 is 5. There's my answer. I'm done. I could have put 1/3, 15, cross multiply, 15 times 1 divided by 3. 15 divided by 3 is still 5. That's okay. I'll cover them all. Rylan rolls a die and flips a coin 20 times. The results are shown in his table. So this is experimental. This is what he did, and these were his results. If Rylan rolls a die and flips a coin an additional 150 times, how many times should he expect to roll an odd number and have the coin land on the tail side facing up? $20 times is important. 150 times is important. I want an odd number, and I want the tail side facing up. So let's go through and find the odd numbers and the tail sides facing up. 1, 2. What else is an odd number?
3.
1, 3, 5. So, is this gonna work? Is this odd and tails?
Yes.
Right here? This is odd, but is this also tails? No. Is this odd and tails? No. So let's keep going. Here's one. Here's another. And is that it? Let me double check. 1, 2, 3 in heads, 3 in heads, 3 in heads, 5 in heads, 1 in heads. I think I've covered it all. So how many do I have here?
4.
And then what do I need to do with that 4? I'm going to put it, let's put in a fraction first so then I can make my proportion as simplest form. So 4 what? 4 20ths. Good. Equals 1/5. Now I can put it in my proportion. 1/5 of the time he will get an odd number with tail side facing up. So then what do I put over here? 150, because that's a new total that they're asking me for, an X. How do I get from 5 to 150? Multiply by what? By what? 5 times 100 is 500. How do I get from 5 to 150? Nope, not gonna work this
5 to
time.
150, you have to divide.
Yeah, okay.
Yeah. Yeah. Yeah.
You can divide by a fraction.
Absolutely, or multiply.
Good. Times 30. She
Vice
said it.
reciprocal.
And then whatever I do to the bottom,
Yeah.
you do to the top. It's called the doo-doo method. Been calling it that for years. Okay, next. Henry has a bag containing 35 letter tiles. What's important? Some consonants and some vowels. He selects a tile without looking and then replaces it. If he pulls 3 consonant tiles and 4 vowel tiles, which is the most likely number of consonant tiles in Henry's bag? So I want to know about consonants. Do I need the vowel number?
No.
Nope. Yes.
You just like line them up with each other, like 3, 4, like that.
For this problem?
Yeah.
No, because I don't need the 4. Watch what I do. Okay? How many, actually I do need the vowel. How many numbers were this that he randomly pulled out? The 3 consonants and the 4 vowels.
7.
He had 7 total. And then what's the 35?
Remember how many tiles
So what is that also?
total.
Another total. Remember, I always need 2 totals when I'm making a proportion. So what goes in the bottom? The number of total tiles. So 7 and 35. Now, what are they asking for? Consonants. So I got consonants in total. This 7, what number of consonants goes with this 7? 3. Because 3 out of 7 of those tiles are consonants. And then what goes over here? X, because I don't know it. So I can cross multiply and divide, or I can figure out what I need to do from 7 to get to 35 and do the same thing. Whatever I do to the top, I do to the bottom. Gotta apply the do-do rule. So 7 times what gives me 35?
5.
Times 5. So then what am I gonna do to the 3? Multiply it by 5 as well. That answer should be there. Okay. Number 2. Javi has a bag of marbles. Sorry, I kind of wrote over it. That are identical in size. He has 6 red, 4 blue, 7 yellow, and 3 orange. What do I need to do with all these numbers? Add them up. 6 plus 4?
10.
7 plus 3?
17. 10.
So 10 and 10 makes 20 total marbles. Javi conducted a probability investigation. Without looking, he drew a marble from the bag, recorded the color, and returned it to the bag. Javi drew a marble 60 times. What's this 60? Another total. And the results are shown in the table. Here's what he got. So he got 15 out of, nope,
60.
out of 60. 12 out of, hold on, out of 60. 21 out of 60, and 12 again out of 60. Now, this question is like the other question because it asks for theoretical and experimental probability. So I have a lot more work to do on this one. So let's simplify these fractions like I heard somebody doing. 15/60. Ouch. What is that simplified? What part of 60 is 15? A fourth. What part of 12 is 60? Or sorry, what part of 60 is 12? A fifth. 21 and 60, what do they have in common? They do have something in common.
6.
Not 6.
7.
No.
3.
Uh-huh.
7.
How many times does 3 go into 21?
7.
And 60.
20.
So what's the fraction?
7 over 20.
7/20th. And then 12/60th again. 1/5. So this is experimental. Right here. My theoretical. What should happen? How many times should I get a red? Out of 20. So red is 6 out of 20, which simplifies to what? 6 doesn't go into 20 evenly. 3 over
10.
blue. 4 out of
20.
4 20ths is what? 1/5. We did that earlier. Yellow. 7 out of what? Good. 7 out of 20. And orange. How many orange? 3 out of, not 10, 20. So this is what should happen. I should get a red 3 out of 10 times. I should get a blue 1 out of 5 times. I should get a yellow 7 out of 20 times. And I should get an orange 3 out of 20 times. But that's not always going to be the case. So when Javi conducted his experiment, he got a red 15 times. Or I'm sorry, a quarter of the time. He got a blue a fifth of the time. He got a yellow 7/20ths of the time. And then he got an orange 1/5 of the time. Which one of these in the experimental probability matched the theoretical probability? Look at the fractions right here, right here, right here, and here. And then 3/10, 1/5, 7/20ths, and 3/20ths. There were 2 of them that matched.
1/5 and 7/20.
1/5 and 7/20ths. So the blue and the yellow matched. Okay? So based on experimental data, Javi is expected to draw a red 30 times out of 100. So this is where I'm making proportions to check to see if they're equal. Y'all following me? Okay, are y'all writing this down? All right, let's go. What is the fraction or the ratio that they give me here?
30 and 100.
30 out of 100. And it's experimental for red. So I need to come to the experimental and look at red. That's 1/4. 1 out of 4. What will 30 hundredths reduce to?
3/10.
It'll reduce to 3/10. Is 3/10 the same as 1/4? No, so F is wrong. Looking at G, theoretical, so this is where I'm looking over here. We should get a blue marble 40 out of 150. Make my proportion 40 out of 150. And then what's the blue over here? 1/5. If I cross out these zeros, is 4/15 the same as 1/5? No, so that is incorrect as well. I'm going to come down here where I have a little bit more space for H. Based on the experimental, so I'm looking over here at the experimental data, Javi is expected to draw yellow 70 out of 200 draws. 70 out of 200, and then yellow. What fraction do I put on the other side?
7/20.
7/20ths. Do these equal each other?
Yes.
Yes. So this is the correct answer. Okay, I don't even need to go to J because I found my answer. Let's double check though, because I think there were 2 answers for this question as well. Think Up Math likes to throw us off. All right, so theoretical, I'm looking over here, and orange, 3/20ths. No, it's not going to work because this will be 1/5, and that is not the same as 3/20ths. So here's my answer. Okay. All right, let's try and knock out one more. Tyler rolls a pair of dice. The results of each roll are shown in the table. How many times did he roll?
407.
No. I haven't even read that part yet. According to the table, 20 times.